Okay, so members, we are going to see how can we get velocity, displacement when we are given acceleration. Please don't forget to subscribe to the channel. Now, you know that if we are given acceleration, to get velocity, you integrate acceleration, the expression of acceleration. To get displacement, you can either integrate velocity or integrate acceleration to time. Anyway, let us see how do we handle that now. If now in this question they are telling us that the acceleration of the particle after 2 seconds is given by this. If initially the particle is moving at 1 meter per second, find its velocity after 2 pi and its distance, it would have covered by then. So to get the velocity, we integrate acceleration. So from here, my velocity will be the expression of acceleration. From here, I see 5 plus cos t over 2 dt. So now I can integrate this. This will give me 5t. Then plus, we integrate cos, we get sine. We differentiate this angle, we get a half. The reciprocal of half is 2. So 2, then sine. The angle 2 over 2, then plus the constant of integration. So now how do I know this integration constant? They're telling me that initially means that when t is 0 seconds, the velocity is 1 meter per second. Putting it here, I have equaling to now 5 into 0, 0 over 2 plus c. This will be 0, sine of 0 is 0, so that our c will be equaling to 1. Writing the expression for velocity again, so that there, my velocity will be now 5t plus 2, then plus 1. So now they are telling me, now there is no, everything is okay. Now they are telling me, find this velocity after 2 pi seconds. So when 2 is equal to 2 pi, my velocity will be 5 into, I'm substituting where there is t. So now this will be 10 pi sine of 180. This is divided by 2, 180. Sine of 180 is 0, then plus 1. This is our expression for velocity in meters per second. So that will be the velocity of this particle after 2 pi seconds. And the distance it would have moved covered by then. The distance now, our distance is given by the integral of the acceleration, of the velocity expression. So now our velocity expression is here. So this will be now integral of 5t to sine t over t, then plus 1, the whole respect to t. So can we integrate? This will give me 5 over 2 t squared. When you integrate sine, you get a negative cos. When you differentiate this arm, you get a half. This also equals 2 times this 2, you get 4. Then cos t over t. Then when we integrate 1, you get t. Then plus a constant of integration. This is our x. So how do we remove this constant of integration? They told us that initially means that when t is 0, of course, when t is 0, we have moved in 0. Now, initially, if now this one was moving at 1 meter per second initially, so the count rate was moving at 1 meter per second. Meaning, if I take it to be 1 meter per second, it means that it has already covered the distance. So initially, the particle was moving, meaning it was covered already some distance. So, meaning that if it was covering, if it was having this velocity, meaning that for every our velocity was 1 meter per second. This means that for every second that was passing, this was covering 1 meter. Meaning that if 0 seconds had passed, it means that at t equal to 0, initially, it was already at this velocity. Meaning that if it was already at this velocity, by that time, had it covered a distance. So, this will tell you that when t is 0, this we are now at, it had never covered any distance. So it's very stable, 0. Why? Because this shows that after 1 second, it would have covered 1 meter. What about after 0 seconds? It had covered 0 distance. So putting here, it will be now 5/2 into 0 squared, cos of 0 over 2, then plus 0 plus k. This will be 0. Cos of 0 is 1. So here I have 0 equal to -4 plus k. From here I start 9k will be +4. So putting it now in this formula, the k, I'll be having now minus equal to 5/2 t squared minus 4 cos t over 2, then plus t, then plus k, which is 4. Then they want the velocity when t is 2 pi. I mean the displacement when t is 2 pi. Why am I putting 2 pi? Because they say find this velocity after 2 pi seconds and its distance it would have covered by then. So after 2 seconds, I want to define that distance. So my s will be 5/2 2 pi squared minus 4 cos plus 4. So here we shall be having 10 pi squared cos, this would be cos of 180 will be -1, negative, this will be 180. Cos of 180 is -1 times this negative, you get 4 plus 2 pi, then plus this 4. So this will give you 10 pi squared plus 2 pi, then plus 8. All this is in meters because distance is measured in meters. So members, that's how we can handle that number. Please don't forget to subscribe to the channel. I wish you the best.
Oh.